Okay, so for this first problem, look at what kind of shape you got first. So just read through the problem. You've got a rectangle. So I noticed I got rectangle written here. So I drew a rectangle straight away because I know we're going to be dealing with rectangles. Look for your keywords. You've got length. So length is normally considered to be the longest side. So the longest. And the breadth, well, that's the same as the width. So that would be the shorter side of the rectangle. Okay, and we see this word exceed. So something is going to be added on here. Okay, so what I did here, I let my breadth or my width be x. So let breadth equals x centimeters. Okay. And here it says the length of the rectangle exceeds the breadth by 4. So if your breadth is x, the length is going to have to be x plus 4 centimeters longer, like that. So we're trying to set up this equation, and that's what you need to do in each question. And that's the trickiest part. Actually solving the equation, you know how to do already. So, and the other information we have is the area is 525, and we need to find the dimensions. So our breadth was x, so our length equals x plus 4 centimeters. Okay, and find the dimensions. Well, that's the length and the breadth. We have to find what x is first to do that. And then here we know that the area is 525. And we know the area of a rectangle will be the length times the breadth or the width. Okay, so if our area is known already, it's 525. So that would be 525 is the length, which is x plus 4, times the breadth, which is x. And you can see now we got our quadratic, not quite simplified yet, but once you get to this stage, you should be able to get the correct answer, and you'll get a mark for doing that correctly anyway. So when you do this in your worksheet, make sure you show these bits of work here, what you let the lengths be, the formula, and then our equation here. And you should have a picture too. So draw a picture. So we could rearrange this a little bit. We'll have x squared plus 4x. I'll bring my 525 over. I will get minus 525 equals 0. Okay, so what I did here, you could factorize this, but I think the quadratic formula is probably quicker because it will take you a while to like guess what the factors are. So for our quadratic formula, remember is x is minus b plus or minus the square root of b squared minus 4ac, all on 2a. So let's go up here. So x will be minus b minus 4 plus or minus b squared, which is 4 squared, minus 4 times a times c minus 525. Right, all on 2a, 2 times 1, like that. And you should end up with minus 4 plus or minus root 2116 divided by 2. You can do that bit with your calculator there. And x will end up being minus 25 and 21. And because we're dealing with lengths, we know we can't have a negative length, can we? So this length minus 25 will be cut off because it's not valid. So x must therefore be 21. Okay, therefore x equals 21 centimeters. So we'll go back to our picture, and we've got x on this side. So x here must be 21. That would be the breadth, for the breadth of the rectangle. And this must be 21 plus 4, isn't it? So that would be 25 centimeters. So those are your dimensions. So that's your breadth, 21 centimeter, and your length is going to be 25 centimeters. So in this question 2, let's look at what we got. We've got a piece of wire. It could be a wire, it could be string or anything that you can change the shape of. That is 45 centimeters long and is bent to form the perimeter of a rectangle. So this is your rectangle here. Okay, and it says it's the perimeter of the rectangle. So you take your wire and you make a rectangle out of it. Okay, and that would be the perimeter. And the area is going to be 72. So this area is 72 square centimeters. And we don't know what the lengths are, okay, but we know the perimeter is going to be 48. So perimeter is 48 centimeters. That's one bit of information. And the area is 72 square centimeters. This is a very common problem you do come across in lots of books. So you're going to see this again in your homework as well. Now, we don't know what this length is, and we don't know what the width is. So let's call the length x here. And let's call the width y, okay? It doesn't matter which is which, you'll get the same answer. So if this length is x, this side is also x, isn't it? And if this side is y, this side is also y. And the perimeter is the sum of these numbers. So the perimeter would be x plus y plus y. So that's the perimeter of your rectangle. But we also know that that equals 48 because that's the length of the wire. So we could write 2x plus 2y, and this number equals 48. Okay, but when we're dealing with problems like this, we don't want to have two variables, do we? Like I mentioned the other day. So we always want something in the form ax squared plus bx plus c equals 0. So I only want x. I don't want this y here actually. So let's get rid of the y. So 2y would be 48 minus 2x. And now I can divide by 2. You'll see why in a minute. So divide by 2. This will cancel the 2 here. And this is a common denominator. So we divide 2 into both parts here. So y is 24 minus x. Okay. So we isolated the y here. But if you go back to your question, your picture, you've got a y here, don't you? But here you're telling me that y equals 24 minus x. So this is 24 minus x there. So instead of using y, I'm going to use 24 minus x because it's the same length, but it's in terms of x, not in terms of y. So then I'll go over here. And I notice that my area is 72. And we know length times the width is 72. And in our case, that was x times y, wasn't it? So xy is 72. So instead of using the y, we're going to use 24 minus x. So we'll take this number and substitute in here. So you'll get x, 24 minus x equals 72. And so now you see you have a quadratic equation, don't you, in X. This was originally Y, but I don't want to have to try to solve that with Y. We need to eliminate Y. So now we just expanded 24x minus x squared equals 72. Now, because you have a minus x squared, I don't like minus x squared or minus 2x squared. I try to get them to be positive. So I'll put everything on the other side. So I'll get x squared minus 24x plus 72 equals 0. Okay. Now, you can't factorize this particular equation. It doesn't factorize. So that means you're going to get decimals for your x and y here. So if you use your quadratic formula, which you know already, you're going to get the answer x equals 12 plus or minus 6 root 2, okay, for your final value for x. Okay, but that's going to give you two particular numbers, which will be 3.51 and 20.48, like that. So in this case, we have two particular numbers that could work. Now, x is the length, isn't it? I've called x the length, and length is normally the longest side. So I'm going to call my x value 20.48. So let's let that equal 20.48. Okay, because the length, I'm letting it be the long side. So that's 20.48 for the length. And your width is y equals 24 minus 20.48. So that will give you the 3.51 on this side, like that. I'm rounding it off to 2 decimals. So if you multiply these two numbers, you won't exactly get 72, but this is okay. This is close enough. You can use 3 decimals if you want, but that's enough. 2 or 3 decimals is okay. So that's your answer for this question. So that would be the width of your rectangle, 3.51 centimeters, and 20.48 will be the length of the rectangle. Okay, so let's take a look at this one here. This is question 3. And as we see the keyword, rectangular swimming pool. So I've drawn that here. I've made a swimming pool, which is in blue, of course. And it says it's 12 meters by 8 meters. So let's call this 12 meters, because that's the length of the pool here. And the width is 8 meters. So let that be 8 meters. Down here. And it's surrounded by a concrete path. So we have a concrete path of uniform width. Uniform means the width will stay the same around the swimming pool. So we can let the width of the path equals x meters. It says it's of uniform width, but it doesn't tell you how wide it is, does it? It just says it's a uniform width. So if you look at your picture, that's saying that the width of the path is x in each direction. So x, 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 like that. And the same way all the way around. So it's going to be x here, x, 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 like that. Uniform width. That's what this word means. So you may see that word again in different contexts. Not the uniform that you wear, your school uniform, but uniform being equal in that sense. Okay, so we've got our picture here. And it says the area of the path is 224 meters squared. So that's the gray part. But let's go back to the swimming pool. So the pool area, because we need that as well, is 8 times 12, which is 96 square meters. Okay, that's the area of the pool, just the blue part. So let's highlight that. So that's the blue part. The gray part is the area of your path. So path area is 224 square meters. So what you need to do here actually is add to give me the total area. So total area, that will be 320 square meters. Keep that number in your mind, this one here. So that's the total area. So that's the blue area plus the gray area, the total area. And the path area is in gray. Okay, but now we need to look at our lengths of the total pool, including the path. So if this is 12, and this is x, and this is x, that means this total length must be 12 plus 2x, isn't it, from here to here? So that's 12 plus 2x, and this is going to be 8 plus 2x here. So this will be 8 plus 2x for the total length, including the path. Okay. In the question, it says find its width. So I should have said width of the path. Okay. So this is width of path. And the width of the path is x. Okay. So we're going to need to find x here. Okay. But what you see here, we've got two lengths, 8 plus 2x and 12 plus 2x. Now, if you multiply those, you should get the total area, shouldn't you, of the complete area. So we'll have 8 plus 2x times 12 plus 2x should equal 320. So that's your key step. This is your quadratic equation now. This will be how you find x here. So from that equation, you could expand this and factorize it. When you do expand it, you'll end up with 4x squared, 4x squared plus 40x minus 224 equals 0. So I'm just shortcutting now. So I'm showing you what you get if you expand the question. So if you fully expand that, you'll get this quadratic here. And the numbers are quite large, so you may want to use your quadratic formula. Okay, so if you do your quadratic formula, you'll get x equals minus 14 and 4 as your final answer for the quadratic formula. But notice one of the numbers is negative, this one. And so you can't have a negative width for the path. It would make no sense, would it? So this number's gone. So your only answer is x equals 4 meters. So that's the width of your path. Therefore, width of the path equals 4 meters. There. So that's your final answer there for that one. Okay, for question 4, let's take a look. Look at our keywords. Area of a triangle. So we're given the area of a triangle. We're given the height is 7 more than the base. Okay, so there's a few key things to look at here. and we want the length and the height. The length of the height, length and the height should be actually both. So we'll calculate both anyway. So when you look at this, you see you've got area of triangle, and area is half base height. That's your formula for the area of a triangle. We see area, so we know we're probably going to be using this formula. So you should write that down at the start. And here it says the height is 7 more than the base. So what I'm going to do here is let the base equal x. X cm. Okay, so the base is x centimeters along here. And the height is 7 more than that. So therefore, height would be x plus 7 centimeters. Okay, so the height of this triangle must be 7 more, like that. So this would be 7 plus x. Now, if you did this differently and you called this the height x, this height x, then this would have to be x minus 7. But when you calculate, you'll get the same answer. Okay, so this is still 7 more than that. Either way will work, so it'll be up to you. But this is the way I chose. So I didn't have any negative numbers in my expressions. That's the only reason. But now we know the area here is going to be 60. So we'll have 60 is half times the base, which is x, times the height, which is x plus 7, like that. And now I don't really want this fraction, so don't expand anything yet. Get rid of that fraction. So multiply every side, or both sides, by 2 and cancel it that way. Or just put the 2 up to the top. You'll get 120 on this side. So 120 is x plus 7. So now we have something that looks like a quadratic. So we'll go here. We will get x squared plus 7x equals 120. Okay, so bring your 120 over. At that point, and then we can factorize this, if you like. So then we'd get x plus 15, x minus 8 equals 0. If you're not sure how to factorize because they're big numbers, then just use the quadratic formula for that step there. So therefore, x could equal minus 15 or 8 at this step. But because we're dealing with lengths, we ignore the negative values. So this one would be gone because we can't have minus 15 centimeters. So your only solution there would be x equals 8. Okay, so therefore, x equals 8. And that's the base. Okay, so this will be 8 centimeters for the base. And this is 8 plus 7. So that will give you 15 centimeters for the height. So in question 5, we've got a right angle triangle, which obviously means that the triangle is right angled here. So we have a right angle triangle is drawn so that the hypotenuse, if you remember hypotenuse, that's the longest side, it will be opposite the right angle. So this is the hypotenuse here. And it's drawn such that the hypotenuse is twice its shortest side. So the shortest side, these look about the same. So let's call that the shortest side here, x. So this is the shortest side. So the shortest side, I let that equal to x. And here it says the hypotenuse is twice the shortest side. So if this is x, this must be 2x, double. Okay, it's twice the shortest side. While the third side is twice the shortest side and less 4 centimeters. So twice the shortest side, less means subtract, less 4 centimeters. It can't be longer than the hypotenuse because the hypotenuse is the longest side. So this must be -4. Excuse me. No water. Anyway. Okay, so this is the middle length side, actually. So the shorter side, the medium length, and this is the longest side. And if you recognize this shape, you'll see you're going to use Pythagoras theorem here. Which says that the sum of the two shorter sides, the legs, will be equal to the square of the hypotenuse. Okay, you've done this already previously many times. So substitute these numbers in. It doesn't matter which is A or B, does it? Because A and B can be swapped around. So let's just make x equal A. So you have x squared plus 2x minus 4 all squared equals 2x squared all squared. Okay, so then we will expand these. We'll get x squared plus 4x squared minus 16x plus 16 equals 4x squared. So just be careful again with your expanding your bracket here. So this became this. That's a complete square. That's a perfect square there. So then we simplify this a bit. You will see that 4x squared is on both sides. So cancel that. You get x squared minus 16x plus 16 equals 0. Now, in this question, you can't factorize it. If you try, you won't be able to do it. So use your quadratic formula here. Calculate, you'll get x equals 8 plus or minus 4 root 3 for the answer, which ends up being 1.0718 14.9282 as your final answer. But this smaller number can be cut, because if you put 1.07 in here, you're going to get a negative number, aren't you? This side will be negative. So, and the length can't be negative. So that 1.07 will be cut. So cut that one off. So therefore, x must be 14.9282. You can round off to 3 decimal places or 2 if you like, because the main thing I'm interested in is your working anyway. So we end up then with the lengths 29.8564. So that's the hypotenuse. The shortest side is 14.9282, which is the x value, this one here. And the middle length was 25.8564. Like that. Because it asks you for the dimensions of the triangle. And the dimensions are each length. So the shorter side, the hypotenuse here, and your middle length there, that one there. Okay, so in question 6, we got a piece of wire, which I've drawn here. It's 76 centimeters long. It is cut into two unequal parts, okay? So I'm not cutting in the middle. I'll just cut about here somewhere like that, okay? So I'll call that side X. So this length of the wire is X, this part here, up to there. And this length would be 76 minus X. So the total is 76 centimeters. So I'll call that X centimeters, and I'll call this 76 minus X centimeters. And when you add them, you'll get 76. So we know we're okay. So this is the way you set up the piece of wire, the lengths of them. And then when we cut the unequal parts, we bend each part to form a square. So this part here, I'm going to bend that and make a square, not a rectangle, perfect square like that. And this bit, I'll do the same here. The squares will be different sizes because the wires are not the same length, are they? Okay. So what that means is that actually the perimeter of your square is X, this one here. So the total length around here is X, and each side is the same. So this length must be X on 4, and this side X on 4, and this is X on 4, and this is X on 4. We can check that. We've got X on 4 plus X on 4 plus X on 4 plus X on 4, which is 4X on 4, which is X. That's your perimeter. So we know this is okay. So if you add these 4 lengths, you'll get X, which is what we want. And we know we can do this because it's a square. Okay, if this is not a square, you couldn't do this. But we know that each of the lengths is the same, and they are a quarter of the perimeter. So we could say each side is 1/4 of the perimeter. Okay, so X on 4, X on 4, X on 4, X on 4, like that. So that's the first one. And we do the same to this one. So this perimeter is 76 minus X. So that must also be divided by 4 for each length of the side. And again, around here as well. So those are your 2 squares. So you've got this blue one here, which is formed from this piece of wire here, being the perimeter. And the yellow one is formed from this one here, perimeter actually. So I should actually color that as the perimeter. So like that. Okay. I think you've got that. So that forms the perimeter of the blue one, and the yellow one, that is your perimeter there. Now, the next part of the question, it says the sum of the areas. Where's my pen there? The sum of the areas of the 2 squares is 205. So what's the area of this square here? That would be X on 4 squared, length times length, okay? X on 4 squared. This area would be 76 minus X on 4, also squared. That's the area of this square here, okay? And it says the sum of the areas is 205. So now we have to add these 2 areas. Let's call that area 1, area 2. So area 1 plus area 2 will be 205. So we just substitute the two areas. So x on 4 squared plus 76 minus x squared. Sorry, x on 4. Yeah, on 4, sorry. Okay. Equals 205, like that. So it looks like a big equation, but it actually simplifies not too badly. So I'll do a little bit of expansion and you can fill in the gaps if you like. So x squared on 16 plus 76 minus x squared on 16. I did that for a reason. I don't want to expand this just yet. I just want to have a 16 here. And that's 205. But now you see here you have a common denominator, 16, 16. So now we can join this into one equation. So we'll have 16 x squared plus 76 minus x all squared equals 205. Now you've got a 16 down here, and we don't really want fractions in our equation. So we'll multiply 16 to both sides to get rid of that, which will cancel this side here. Okay. And then we'll end up with x squared plus 76 minus x squared equals 3280. Okay. Now, if we expand that fully, we'll end up with this equation. You'll end up with 2x squared minus 152x plus 2496 equals 0 by expansion. Okay. Now, at this point, the numbers are really big. So you probably want to use your quadratic formula. And you'll get the answer x equals 24 and 52. And you'll see that these answers can form the answer. So, and it wants actually the shorter part of the wire. Find the length of the shorter part of the wire. So we would choose the shorter length, which is 24 here. And then we'll go back to this picture here. So we can see x on 24, x on 4 would be 24 on 4, which will give you 6, 6, 6, 6. Okay, so let's highlight that. So that would be the length of this part here. We don't need to go to the other one to get the answer. We don't need to use the 52. So your length of the shorter wire is 6 times 4, which is 24 centimeters. So that's actually your answer there. That's the length of your shorter wire. If we go back up to here, we can see that this is 24. And this one is 76 minus 24, which will be 52 from the answer we just did below. So even though my picture, this one looks longer, it's actually, I've made it shorter. Okay. So this is 24, that's the shorter piece. And this is the longer piece. So this square here is actually smaller than this one here.